All right, so this is AP Calculus. We are doing the Unit 5 Pretest Antiderivatives. Here we go. Number 1. Again, this is a problem from, I think, is it Unit 1? It's definitely review. It has vertical tangents here, here, and has horizontal tangents here. Where is f not differentiable? Name me 3 things that are not differentiable.
Well, sharp corners.
Sharp corners. There it is.
Vertical tangents. And discontinuity.
There they are. Vertical tangents and discontinuities. What are the 4 types of discontinuities? Holes, gaps, endpoints, and VAs. Yep. All right, so we're looking for anything on this list here. So I have vertical tangents here and here, and I have a sharp corner there. So there's 3 things that are bad, that are not differentiable. One happens at -1, one happens at 2, and one happens at 1, one happens at 2. So -1, 1, and 2. Correct answer is D. Moving on to number 2. If y is a horizontal asymptote, what is the definition of a horizontal asymptote? It's where take the limit as x approaches infinity. And it can be positive or negative infinity, so both of these are okay, but it needs to both equal 7. So that one equals -7, so that's not cool. It's just E. Just a definition problem there. Okay, we have a hotbox problem, number 3. So I know it's a hotbox problem because I have h goes to 0 and h is on the bottom. So I'm going to take the top left, the thing that has stuff adding to h. That means that my c is equal to e, the thing that's being added to h. I cross off everything in there. Now I know my function is the natural log of that x. So my f of x, my function, is the natural log of x. Okay, since this is the definition of the derivative, I'm going to take the derivative. This is f prime of x. And what is the derivative of natural log of x? Yeah, so 1 over x in this case. And then I plug in my c, so it's 1 over e. So 1 over, oh, it doesn't even ask me that. So it's saying f prime of this e, so f prime of e, so it's not those. F prime of e, where our f of x is equal to natural log of x. We just said that right there. So yeah, correct answer is A.
I got this right and I got it wrong on the test from pre-cal. So I remembered it. Because I remember on pre-cal I put, what did I put? I put c, because I didn't put the e in f prime of e.
Okay. Yeah, that's good, right? Pre-calc is helping. Number 4, I'm taking the derivative of all those. I don't like fractions. I don't like fractions. I don't like radicals. I do not like them semi-am. So you need to get rid of them by making them negative powers, -3 and x to the -1, and I still have x squared. So I'm just rewriting my function before I take the derivative. Now that I take the derivative, -3 comes down in front, -3x, and then I go down a power, -4, minus, it's actually going to be plus because negative times a negative is a positive, x, and I go down a power, and then this is going to be plus 2x. And then I'm going to immediately plug in -1, so now this is going to be equal to -3 over, I don't know if I'm skipping too many steps by saying this is -3 over -1 to the power of 4. Is that skipping too many steps? Because when I have x to the power of -4, that comes into the denominator, and then I plug in -1 for x. Can we all follow that? If not, I can explain it a little bit more thoroughly. Explain it thoroughly?
No.
Okay. And then I'm going to go ahead and say plus 1 on the top, and then -1 to the power of 2 on the bottom, plus 2 times -1. Yeah, you have to turn them into fractions because of the negative powers, and then make them positive powers. Whenever I have anything to an even power, it's always going to be positive unless you're dealing in complex land, which we never are in AP Calculus, so that means these are basically just gone. You can ignore them because it's really -1 to the power of 4 is positive 1, -1 to the power of 2 is positive 1, which means it's -3 plus 1 minus 2. So that is -4. Correct answer is B. All right, so we are on to number 5. How many extrema do I have? And it gives me f prime. So what is the definition of f relative extrema? So let me write this down. What is f relative extrema's definition? It's where, is it f prime or f double prime? F prime. F double prime is when you're talking about inflection points. Extrema are just f prime. F prime, sign change, there it is. Sign change. And I can only have a sign change with what type of power? Odd powers. So I'm looking for odd powers here. So I have a sign change once and not there. So just once. All right, that was number 5. Let's go to number 6. We have this guy, and we're looking for the equation of a line tangent. So whenever I'm doing that, I'm saying, okay, y minus box is equal to box times x minus box, where this is going to be, I guess it's technically f of that x coordinate. This is that x coordinate, and this is the f prime of the x coordinate. So what is our x? X is, where is it? There it is, yeah, -1. So this is going to be -1, and then I plug that into this. So this is now going to be f of -1. When I plug in -1, it's going to be 4 times -1 to the power of 3 minus 5 times -1 plus 3. So -1 to the power of 3 is -1. Again, odd powers, you keep the negative. So 4 times -1 is -4. -5 times -1 is a +5 and a +3. So 5 plus 3 is 8. 8 minus 4 is +4. So I have a +4 here. And then what is the derivative? So it doesn't tell us, so we have to find f prime of x. F prime of x, there it is equal to 12x squared minus 5. No questions about that. We're good. Okay, so, and then from here, I'm going to plug in -1. Again, I'm plugging in this x here and here. So when I plug in -1, I get 12 times -1 quantity squared minus 5. -1 squared is 1, so 12 minus 5 is 7. The slope here is 7, and that makes sense. So it immediately cancels out d and e. And then from here, I need to add 4 to both sides. After distributing the 7, double negative means this is going to be plus. So I have 7x plus 7. And then I need to add the 4 as well, so plus 4, and that is my function. Y is equal to 7x plus 11. The correct answer is C. All right, we are on to number 7. Capital F and lowercase f are continuous functions such that if I take the derivative of capital F, I get to lowercase f. AKA, if I take the derivative of lowercase f, I go to capital F. It's the other way of going around saying that. So I need to take the definite integral. So if I take the definite integral, the antiderivative of lowercase f is capital F. So this is going to be capital F of x, and then evaluation bar between a and b. Evaluation bar a and b. When I do that, that is now going to become capital F. I'm going to plug in b first, so f of b, minus when I plug in a, so minus capital F of a. And where is that answer? It looks like it's C. No, D. There we go.
How come there's a balloon in your hat?
I've had that balloon in there for about 2 months because I found a balloon and I put it in there and it fit. And someone just reversed it like not too long ago. It should be this way. There we go. Nope, not in the least. It does add the possibility of it popping via a staple, but that's about it. So you might be in for a surprise one day, right? I do a quick head nod. Okay, so we have these 3 regions, and it tells us that the area of each of them is 2. So A is -2, B is +2, C is -2, and I need to find the definite integral between -3 and 3. So all of this, right? So I can take it's kind of like distributing the integral here. So this is kind of like the definite integral between -3 and 3 of just f of x, of course dx. And I'm going to add that with the definite integral between -3 and 3 of 1 dx, of course. When I do that, this thing is pretty easy to find. So I just have to add up all the area. This is just talking about the area diagram. So I'm saying -2 plus 2 minus 2, that evaluates to just -2. This guy is the shortcut, right? The shortcut says do top minus bottom, so 3 minus -3, or 3 minus -3 is 6, and then multiply that by whatever number is here. 6 times 1 is 6, so this evaluates to 6. Again, that shortcut, I'll write it up here in case you forgot it. If I have the definite integral between a and b of some number or some constant, that is equal to, you do b minus a, and then you multiply that times whatever that number is. In this case, that's 3 minus -3, 6 times 1 is 6. Okay, and then -2 plus 6 is 4. Correct answer is C. Questions? Get your questions here. All right, we are on to number 9. All right, so this looks like a lot of hard things. So I'm immediately thinking probably taxman, but I also don't like fractions. Let's go ahead and get rid of that. So I'm rewriting this before I take the integral, the antiderivative. I still have that x squared on the top, but now I also have this e to the negative x to the power of 3. Again, that negative applies to the x, not the 3, because it's the immediate power to whatever e was. And of course that d of x, just stay informal about it. Okay, so now I've rewritten my fractions. Now I'm looking to take the antiderivative. And again, it's the same 4 steps over and over. What house am I in? E house. Where's my inner? My inner is whatever the power is. And then therefore, what's my dinner? My dinner, inner, aka my u prime, is equal to negative 3x squared. And my fourth and final question is, do I need to use taxman? Yes. Okay, so taxman.
How do you use, what do you do with the x squared?
Oh, it should eventually cancel out. This x squared and this x squared should cancel out with taxman. Let's see how it works. So taxman, again, I need a u, I need my taxman, and I need my u prime. The 3 things over and over and over again. My u, we already identified, it was negative x to the power of 3. Negative x to the power of 3. The reason I list these 3 things is so you always identify, hey, what is my inner? What is my, this x, negative x cubed? Okay, taxman, he's knocking at the front door. There he is, x squared. And then I take the derivative of u, and I already found u prime. It's right over here. It's negative 3x squared. And then I'm going to pay taxman this fraction, and the x squares cancel out, and I'm just left with negative 1/3. So I'm going to rewrite this integral now. And I realize I'm talking really fast. I should let you catch up.
I think you're good.
You think that. That's good. But do they think that?
That's true.
Now they think that. Okay, so now I can move on, and I can say, okay, I'm rewriting this integral. Let's change the black here. That's the color I haven't used. This is now the integral of, I'm paying taxman, 1/3. This x squared changed into negative 1/3. And I rewrite this e to the negative x to the power of 3. Dx, being formal about it. And then now I can actually write my antiderivative. I don't have to worry about any anti-chain rule because that's the whole point of taxman. And this is now negative 1/3 e to the negative x to the power of 3. E house is really now nice. E house going forwards and backwards is just e house. And then there's no definite integral. I do need to do the plus c now that I've gotten rid of the integral symbol. And where is negative 1/3? It looks like it's b.
You have to
No.
write down the e to the negative x.
Oh, I do. Yeah, that's a
So
positive.
then it's negative 1 divided by 3 e to the negative x.
There it is. C.
C.
Yes. Yeah, thank you for catching that. You can log the extra credit point. Yeah, this should make it so it goes down and becomes positive. That is a positive power right there. All right. That was number 9. Let's go on to number 10. It looks like I have anti-product rule, and the only way that we know so far how to do that is taxman. So it's going to be taxman again. Taxman again, 3 things. We need our u, we need our taxman, and we need our u prime. So u, what house are we in? The same 4 questions. What house are we in? E house. And then therefore the inner of E house.
So what do you look at first, the x to the third or the ex to the fourth?
Yeah, you look at both of them. You say, okay, well that would be powerhouse, but E house kind of trumps powerhouse. If I'm like playing poker, E house is better than powerhouse. E house is the house that's harder to get rid of. So I'm going to consider myself in E house for this one. If you ever see natural log in an x to the power of 3, assume you're in natural log house. Powerhouse is kind of like the base house. If you don't know, you're probably in powerhouse. But if you see sine, tangent, cosine, secant squared for that matter, E, natural log, any of those, that's the house that you immediately pick, and then powerhouse is your default if you don't know. So this one is definitely E house, and my U for E house is always the power of x to the power of 4. So I'm going to write U is equal to x to the power of 4. Taxman, he's knocking on the front door. Here he is, x to the power of 3. And I take the derivative of U, and that's going to 4 is going to come down in front. So 4x to the power of 3, and then I'm going to go ahead and take the fraction. I should switch to blue. I haven't used that color yet. And those x cubes cancel out, and I'm left with 1/4. So when I rewrite my integral is still the definite integral between 0 and 1. But now this x to the power of 3, this taxman has been paid with 1/4. So pay the taxman 1/4 e to the x to the power of 4 dx. Now I can take the antiderivative. Antiderivative of E house, again, it's really nice. You just list it as E house. So it's still 1/4 e to the power of x to the power of 4. And that's evaluation bar. There's no c this time because it's a definite integral between 0 and 1. Let's see what happens when we plug in each. So when I plug in 1, you plug in the top first. It's going to be 1/4. And I'm going to leave that 1/4 outside, and I'll distribute it in later if we need it. That 1/4, and then we have e to the power of 1 to the power of 4 minus e to the power of 0 to the power of 4. All right, so e to the power of 1 to the power of 4. Well, 1 to the power of 4 is just 1. E to the power of 1 is just e, so there's e. And e to the power of 0 to the power of 4 is just 1, so minus 1. And my final answer is 1/4 e minus 1, and it looks like that is A. All right, and we are on to number 11. What house are we in? Trig house. And what is the inner of trig house?
3x.
3x. What is the derivative of 3x? 3. Therefore, do we need to use taxman? Yes. Yes, because it's not 1. So it's over and over again those same questions. What house? What's your inner? What's your derivative? And finally, do you need to use taxman? And generally, because it's a hard test, you are going to be using taxman quite a bit. So taxman requires 3 things, u, taxman, and u prime. We already figured out u and u prime. Taxman, there's no taxman, so we consider that 1. We pay taxman the variable rate of, or not the variable rate, but the rate of 1/3. So our integral now becomes the definite integral between 0 and pi over 3 of 1/3 sine of 3x dx. From here, I take the antiderivative of sine. So anti-s, s stands for same. So anti-same is change. This is now going to be a negative sign, or negative cosine. So I have negative 1/3 cosine, and I still have that 3x on the inside. And evaluation bar between 0 and pi over 3. Now it's time for me to actually plug in these values. So it's going to be negative 1/3. Again, I'm going to kind of factor him in at the very end. And I'm going to do cosine of pi, because 1/3 of 3 is 1. So cosine of pi minus cosine of 0. Cosine of 0. Ran out of room there. So everyone point to pi. Where's pi? Good. Yes, pi is out here to the left. So on my unit circle, there's pi. And where's 0? Out there to the right. And that's 0. And what is cosine asking for? The x or the y coordinate? X coordinate. What is the x coordinate of pi? Negative 1. What is the x coordinate of 0? 1. So it's negative 1 minus 1. That's negative 2. Negative 2 times negative 1/3 is positive 2/3. On to number 12. All right, we have this piecewise defined function, and we need to take the derivative. So we're going to take the derivative in pieces. Here we go. I am going to say this is going to be the integral from 1 to our suspect point of 3 of the left piece, which is going to be 2 dx. And I'm going to add that with the other piece, which is the integral between, I'm starting again at the suspect point to the end, so 3 to 5. 3 to 5 of my other function, my right-hand function, which is x minus 1, all of that quantity d of x. Again, d of x needs to be applied to everything in the function. It needs to multiply by it. That's why I put parentheses. All right, now we need to actually do the antiderivatives. What is the antiderivative of 2? 2x, there it is. You don't actually, I guess you could do the shortcut too, right? How many of you prefer shortcut? How many of you prefer antiderivative? Shortcut 1, antiderivative 2. Shortcut, shortcut. Let's do the shortcut then. So shortcut says do 3 minus 1 and multiply that by whatever number you have. 3 minus 1 times 2, which is going to be 4. You do have to do the antiderivative here because I don't have a constant function. So it's going to be x squared over 2 minus x, and that's the evaluation bar between 3 and 5. When I actually do that, it becomes 5 squared over 2 minus 5. That was the first piece, minus the second piece when I plug in 3, which is 3 squared over 2 minus 3. All right, so I still have that 4 out front, so I'm not going to forget him. So this is now, my final answer is 4 plus, and then these two I have to evaluate. So 25 over 2 minus 5. So I'm just going to write that as 25 over 2. I'm going to leave some space. You'll see why. Minus 5. And then 3 squared over 2 is 9. So this is going to be minus 9 halves. So minus 9 over 2 there. And then be careful here. Minus, this minus sign is distributed. So minus times a negative 3 is a positive 3. All right. So I have 25 halves minus 9 halves. 25 minus 9, that's 16. So 16 halves, that's really 8. So this whole thing right here is just 8. So I have 4 plus 8 minus 5 plus 3. So 4 plus 8 is 12. 12 minus 5 is 7. 7 plus 3 is 10. Correct answer is 10.
This one I drew out because I forgot how to do this. So I like drew the graph and I was like, okay, this.
Oh, dang. Nice. Yeah, and you could because it's just triangles and rectangles. Did you get the right answer?
Yep.
Oh, man. Nice. Yeah, that's the multiple representations. That's awesome. You have that high conceptual understanding. Number 13, we have this piecewise graph, and we want to find the definite integral between -1 and 4. So -1 begins right there, 4 ends right there. So I need to find all this area. Remember, this bottom area is negative. We're just splitting it up at this point. So this is going to be a triangle. It's 1 by 2, and then divide by 2, so it has an area of 1. This is a rectangle. This rectangle has an area of 2. This triangle has an area of 1. This triangle down here is 1 by 1, and then divide by 2, so it's an area of -0.5. And this is going to be -1. Are we okay finding areas? We're good? All right, and then, so 1 plus 2 plus 1 is 4, so 4 minus 1.5 is 2.5. B. All right, on to number 14. All right, this is just a straight-on antiderivative, but I can't because what? Okay, let's ask the same 4 questions. I need to make sure I'm always using the same 4 questions over and over with the antiderivative. First question, what is that question? What house are we in? What house are we in? You answer it now. Powerhouse. And then the next question is, what is the inner? What is the inner of powerhouse? It's nice and easy. It's this 3x plus 1. And then what's the derivative of that inner? What's dinner? 3. And do I need to use taxman? Yes. Okay, so let's go ahead and set up taxman. I need u, which we found was 3x plus 1. I need taxman, which we haven't found, but that's pretty easy. There's no taxman. And then I need u prime, which you told me was 3. And then I'm going to pay taxman the rate of 1/3. So our integral now becomes 1/3. And I can leave that on the outside or the inside. It doesn't really matter. I'm going to just randomly choose the outside. And I'm still having 3x plus 1 to the power of 5 dx. So after paying taxman, I'm now going to take the antiderivative. That means this 3x plus 1 is going to go up to the power of 6 and then divide down by 6, which is really the same thing as multiplying by 1/6. And I still have that 1/3 out front. And then we need to do plus c as well because we got rid of the integral symbol. So we're looking for something divided by 18. Oh, there it is, A. On to number 15. And what time do we get out of here, by the way? We have 5 minutes. We can do this, maybe. We need to distribute, or we need to multiply this x into here because we can't. Oh, do we? Actually, we don't need to. We can rewrite this, of course, as who is it?
I don't know.
Geo. Welcome, Geo.
Gio, can't have your chair. Thank you.
This is going to be the integral of x times 4 minus x squared. All this to the power of 1/2. What house are we in? Powerhouse. What is the inner of powerhouse? And therefore, what is dinner? -2x. And therefore, do we need to use taxman?
Yes.
We do indeed. All right, so our u, you said it was 4 minus x squared. Our taxman is x.
Do you have it fixed?
I thought I handed them out. I might not have.
Wait, actually, I have it, but it's in my class.
Okay.
Can you just review my own and do it right now?
I could, but I have 3 minutes left, so I'm going to go through this video. U prime is -2x. I'm going to pay taxman. These x's cancel out. This is going to be -1/2. So this rewritten integral is integral of -1/2 of this 4 minus x squared to the power of 1/2. Then I go ahead and take the antiderivative. This is going to go up to the power of 3/2. I still have this 4 minus x squared. And out front, I still have the -1/2, but I also have dividing down by this 3/2 is 2/3. So it's, maybe I should move this down a little bit. No, grab all of it. So this is going to be, come on computer, don't fail me now, 2/3. And I'm looking for something that has, the 2's will cross cancel, so something that has -1/3 in it. And it looks like the answer is E. On to number 16. Again, I don't like fractions, so I'm going to rewrite this as x to the negative 2, and I'm going to take the antiderivative of that. That's going to be x to the negative. I'm going to go up a power negative 1. I divide down, it's going to become negative x to the negative 1. Evaluation bar between 1 and 2. When I do that, I'm going to get negative 1 over 2 is the first side minus negative 1 over 1. Again, I'm plugging this. I turn it into a fraction because it was a negative power. So these are the numbers that I'm plugging in down here. And whenever I do that, it's going to be plus, because double negative, and it should be 1/2. C. I know I went through that really fast. The video's up.
Where the two negatives make a positive sign came from?
Yes. Number 17, my derivative is cosine of 2x. So to get back to the normal, I have to take the antiderivative. So antiderivative, I'm going to need taxman again. So u is equal to 2x. Taxman, there is no taxman. U prime is equal to 2. I'm paying taxman 1/2. So my integral is now 1/2 cosine of 2x dx. I'm going to go ahead and take anti-change, which means same. It's the same sign. It's still 1/2 sine of 2x plus c. 1/2 sine of 2x plus c is c. Moving on to number 18. Antiderivative, pretty straightforward, is going to be 2x to the power 4, divide down, plus 3x. Evaluation bar between 0 and 2. That is going to become, this is really 1 over 2, so it's going to be 2 to the power 4 over 2 plus 6. All of that is the first. When I plug in 0, I get 0, so don't worry about it. 2 to the power 4 is 16 over 2 minus, or plus 6. 8 plus 6 is 14. Correct answer is C. Moving on to number 19. This one is powerhouse. So I need to use taxman, and taxman doesn't work on this one. So this one I actually have to I have to multiply it out. So it's going to be whenever I have something squared, square the first, double the product.
Anticipate when taxman isn't going to work.
Taxman isn't going to work because u prime. So u prime is 2x, and our taxman was 1. I can't pay taxman a variable rate.
Okay.
So that doesn't work. This is going to be x to the power 4. So square the first, double the product, square the last. So there it is multiplied out. So now I have this thing, dx. Take the antiderivative, and I get x to the power 5 divided by 5. This is going to be 2x to the power 3 divided by 3 plus x. And don't forget your plus c. Where is that thing? It looks like it is e. And you guys can leave. I'm just going to keep recording number 20 to make sure you have the entire video up. For this one, I do need to rewrite it. This is going to be x times x squared plus 1. And that's going to be to the power of negative 1 because I'm bringing it up. And this is still the definite integral between 2 and 3. Don't forget our dx to be formal. And then I'm going to say, okay, I'm obviously using taxman, so u is equal to x squared plus 1. I'm in powerhouse. Taxman, he's x. Or she's x, I don't know, u prime, that's going to be 2x. So when I pay taxman, that's going to be, x is canceled out, that's going to be 1/2. So it's now the definite integral between 2 and 3 of 1/2 x squared plus 1 to the power of negative 1. And this is kind of that rare one where, and you can kind of tell by the answer, you're going to have a natural log because when I take the antiderivative, this is our special natural log rule. Let's go ahead and do that. So taking the antiderivative, I still have that 1/2. I'm going to leave that out front, and this is going to be, yeah, so 1/2, I'll leave that out there. This is going to be natural log now of whatever that inner was. So absolute value of x squared plus 1. And I can distribute that. I guess I didn't need the square parentheses. So you might be asking, Mr. Sandell, why didn't they do absolute value? Well, that's because x squared plus 1, that can never be negative. Choose a value, 2, 0, 5, negative 5. All those values are going to be positive, so I don't need the absolute value. You can kind of just drop them. You don't even have the parentheses if you're being super informal. Now let's go ahead and, I should have been finishing this problem. Evaluation bar, ran out of room between 2 and 3. So when I plug in 3, I have that 1/2 is still factored on the outside. I have natural log of 3, so it's going to be 3 squared plus 1 minus the natural log of 2 squared plus 1. All right, and that's going to be 9 plus 1 is 10. That's going to be 5, so it's going to be natural log of 10 minus natural log of 5. Don't forget that 1/2 that we still have to worry about. And do we see that? Half natural log of 10, half natural log of 5. Yeah, there it is, E. And that concludes our pretest.